Okay, good morning, folks. So I did this in class last week, but there was a good few of you out. This is the 2011 surface geometry question, and I'm going to do the whole lot of them. Okay, so keep paying attention to the OneNote and the YouTube channel for instructions. Now I've done the basic setup. That is as much as you can do, and I will be doing that in all the questions just to save time and keep the videos a bit shorter. Okay. Now, if you're looking at the question there, that's as much as we can do. We know that A is going up at 50 degrees. We're also given in the question that B was at 50 degrees, okay? And that was it, bar the few other measurements on the question itself. So anytime you see something like this here, okay, so we're going to be stuck for a point down here where the roofs actually meet. So you always ask yourself, all these things are based on triangles. What do I know? So we know that B is going up at 50 degrees. I also know that is the height of B, okay? So let's set up here an auxiliary view. And auxiliary views really are the name of the game. I mean, there's more than one way to solve things in drawing, as you well know at this stage. However, I find for surface geometry, just doing auxiliaries is the handiest way of solving many things. So we get the height here. So set up your compass there. I'm going to mark off the height. Now I'm just going to mark an arc up here. Okay, and from this point, that point there, I'm just going to bring up a line. Now that height there, okay, is the same as this height here. Just transfer it over. So I know somewhere along there that B, the top of the roof at B would hit that point. Now I also know that B is going up at 50 degrees, same as A. So I can throw down my protractor there, mark off 50 degrees, and draw the edge view of B. Okay, now that's the edge view of B. This point here is what we're looking for. Okay, we now know that point, and what we can do is we can bring it back down from the auxiliary into our plan, drop down that point there, and that'll find this point here now for you. Okay, so by the way, if you're wondering, this set square that I have is an adjustable set square. They're very handy for intersection of solids especially. I sometimes use it. Okay, so anyways, we'll drive on. So now that I have this point, I can draw this line across here. Okay, what else can we do there? We can also bring down this line here now. Bring down that line as well. Okay, and we can finish out this little piece. And I can draw in this guy here between A and B. And we also get out the line PQ. It's P, and there's Q up there. This will be surface C, of course. Now we can draw a line down here going at 45 degrees as given in the question. Light construction line, bring over that guy there. And that'll find us R down here in the bottom corner. And we know R then is coming up here. Now we don't, do we know where he stops? We do actually, there's a piece of information there. 20 mil over and 20 mil over. So if you come over 20 mil from R, do a line up, that would get us S. Now I'm going to join S to Q here as well. Now I can't finish out E at the moment. Okay, I can do a bit of it. I can go over that line there. Okay, that's as much with the plan view I can do for a moment. So I'll do a bit more now with the elevation. That. He'll be on the ground. Now we'll take across this guy here. It's Q. And we have the top of B here, and that we're going down to the base of B, that line as well. Okay. Now, I need to find the top of S. Now, different ways about going about that, probably, but the handiest way I would find for that would be to triangulate this here. So, if we broke that into 2 triangles, okay, I'll actually break it into 4. Now, I know where R is in elevation. It's directly above me here. So I can make one of those green lines from Q to R. Now, I know P is going to S, but where to stop? Well, I know the lines crisscross here at this point. So if I was to bring up that point there, that'll find this point up here in elevation for me. Now, if I start a line going from P through that point, that would get me S up there. Now we'll use the same thing after a while to help us finish out the other surface E, so that's D. Okay, I can join S to R now. Now, that's as much as I can do for the minute. The next thing we've been asked to do in the question, we will finish out this, but we'll use it, we'll finish it out. Actually, we can go ahead and we'll do this. So the surface D and E there, the only piece of information we are given about that is that it has a dihedral angle of 125 degrees, okay? So ask yourself, what do I usually do when I'm drawing a dihedral angle? Well, usually we get the line of intersection, which we have here, is the line RS anyways. We need to get a true length of that, okay? So we're going to look in along here at 90 degrees. And we'll get the true length of this. Let's get the set square there. Now set up an XY line anywhere there. We'll set it up somewhere pretty close. That'll be X1, Y1. Okay, so R is on the ground now. And S has a height of, I'll make it 59 there. Yes. So that's a true length now, okay? The true length of the line RS. Now, usually we bring along a couple of points with us, okay? So I'm just going to pick a point here, anywhere. We call it point N, okay? And so N and R would actually be on that point there as well. Now, next thing we're going to do, we need to set up our second auxiliary. So we need to see this line now as a point view in order to set up that kind of V shape to get a dihedral angle, okay? That's what we usually do as standard. So we extend on this line here now. I hope I won't run out of page space. Put down here X2, Y2. Okay. And I'm going to mark off the line RS as a point. Now you always know, sometimes people get bothered on this, which one do I measure back from, which XY line? Well, it's two, this is a new view, it's 2 views back always. New view, 1 view back, 2 views back. Another way of thinking what I used to do in college was that R and S have to be the same distance from the XY line, and only if you measure from here will you get that, so that you would see the line as a point. Because if you measure it from anywhere else, what you would get is, that's the line RS. If you measure from anywhere else, you get a line. Only from here you get a point, okay? I'm also going to need to measure back in. The distance to in there. And he's right on the edge of my page there. So, okay, point in is right there. Now I'll draw that. That gives me one wing of the dihedral angle. Now we did have the angle itself we were given, which was 125 degrees. So there's 120, 125. And that was the given angle. Now we still need we still need to find a point over here. So how do you do that when you're working backwards like this? Okay, well, what we're going to do is we're just going to take a distance, because we know the distances two views back are the same. If we found any point on the line that we're looking for here, we'd be able to start or draw through that point and go on over here to hit this construction line coming down. That would let us finish off the surface E. So what we'll do is, I'm just going to keep it fairly close. I'll come up there. I'll say that whatever distance, you pick a distance there yourself. I'm not actually going to say what distance that is. It doesn't matter. Keep it fairly close to the line RS. Okay, you don't want to keep it way away from it. Now, and I'm going to put in that line there. Now, whatever this distance is here, I'm going to take this distance and I'm going to remark it off back over here. Now that, what good is that to you? It still hasn't found me a point. Not yet, it hasn't. But if I take this point X now, where it crosses that wing, one of the wings on the dihedral angle, I can bring this back now through the views. So I'm going to bring it back down here. I'm going to bring it back over here. And that's going to find me what I'll call point X there, okay? So it has to come back down parallel to your projection lines and then back this way, because that one was parallel for the projection line. Okay, so that'll get me my point X there. So I'm just taking a random spacing where it crosses the wing there. I set the same distance back, two views back, and when I brought back down the point, that gets me X. Okay, so now I'll be able to finish out the surface there in plan view. Okay, and I'm going to quickly do the same thing I did a while ago. I'm going to split this into 4 triangles here. So I know this marker is going dry on me. So I have this point is on, we call it T. T is on the ground there. And I want point U now, we'll call this U up here on the top, okay? So what I can do is I can join S to T. Now if I get this point here, by bringing it straight up, basic orthographic, that'll get that point up there on that line. And then I'll be able to run a line from or through that point till I hit this line, and that'll get me point U up there. So I can finish out my elevation now. Now the last thing we're asked for there was for a dihedral angle between A and B. Okay, so what do you do in that? We've worked backwards there doing that. This one, what you do, you look at the line of intersection, you identify it. Next thing you need then after that is you need to get the true length of it. Okay, so we'll do this quickly now. Now again, I hope this is all going to fit my page fairly handy. So set up an XY line there. Have the height from over here. That'll give me my true length. I bring 1 point from each plane. Anywhere at all. Easiest to take somewhere on the ground though, and you won't have to be looking for height for them. So that's 1 and 2. That's points 1 and 2 up there. And now, so we looked in here to get the true length. Okay. Now we're going to look down along it here. Looking this way, and we'll bring both them points down there. And it's kind of crisscrossing over our earlier auxiliary, but we'll be okay. Put in x2, y2 there. Now, this is a long way back. So what I'm going to do is I'm going to put in a temporary measuring line. Okay. So I call it a datum line. DL datum line, okay, just a temporary measuring line, and we'll measure all our points off that. Okay, so that's the distance for the line there. That'll get us the line of intersection there. That's it there. Measure back then for points 1. And point 2. And that lets us get our dihedral angle. That's that question finished, folks. I hope you found that useful, and there'll be more videos to come. Okay, so pay attention to the OneNote and keep watching the YouTube channel. And if you have any questions, throw them up in the collaboration space if you have any problems there. Okay, so hope you enjoyed that. Good luck.